Good morning, sir. Dr. Raju, sir.
Yeah, hi, good morning. How are you doing?
Yeah, I'm fine, sir. How are you?
I'm doing good, thanks. It's all working well. Just give me a few minutes. I'll just grab a cup of tea. Just give me a few minutes.
Yes, ma'am. Yes, sir.
Thanks. I'm back. It's all working well. Thanks so much.
Yes, sir. Take your time.
Yeah, just give me 2 minutes. Thank you.
Good morning, sir.
Good morning. How are you?
Yeah, I'm fine, sir. So should we start? Do you want
Yes,
to
whenever
share?
you're ready. Sure.
Yeah. Do you want to share the screen once to check whether
Yes. Yes, let me share the screen. 1 second, please. Yeah, I'm going to share it right away. Let me know if it's. Yes, can you see the screen?
Yes, sir. Yes.
And now it's full screen. Is that okay?
Yeah.
Wonderful.
Yes, sir. Yes, sir. It is changing as well. Yeah.
Very good.
So we'll start now, sir. Uh,
Keep my memento here too.
Yeah. Sir, can you please stop the screen sharing now? So we'll start with the I'll just start with the speech first, and then we'll start with your expert lecture, sir. I'll introduce you first, and then we'll start. Yes. Good morning, everyone. I'm Professor Yogesh Kherde, Civil Engineering Department, YCC. Welcome you all for the third day of IETE approved International Faculty Development Program organized by International Relations Office in association with Department of Electronic Engineering, YCC Nagpur. It's a great pleasure for me to introduce our today's first session speaker, Dr. Rajiv Shore. Heartily welcome you, sir. We are honored to have you for today's session. I feel elated to introduce Dr. Rajiv Shore to everyone today. After all, sir is a living inspiration to all of us. The well-known tagline, never settle, suits best to sir's journey of excellence. Dr. Rajiv Shore is the CEO of University of Queensland, IIT Delhi, Academy of Research. Sir serves as an adjunct faculty in the Computer Science and Engineering Department at IIT Delhi. Sir also worked as an honorary professor at University of Queensland, Australia. Dr. Rajiv Shore completed his BE degree in Computer Science and Engineering from IISc Bangalore in 1987. Dr. Shore received his MS in 1991 and PhD in Electrical Communication Engineering from IISc Bangalore in 1997. Dr. Shore's career spans several reputed research labs such as TCS Research and Innovation, General Motors, India Science Laboratory, IBM India Research Laboratory, and Saskane Technologies. Sir served as first president of NIIT University from 2009 to 2013 before joining TCS Research Lab in 2014. Dr. Shore has contributed immensely in several domains such as wireless networks, 5G networks, telematics, IoT, industrial IoT, IoT security and automotive networks, intersection of AI and machine learning with communication networks are just few of them. Dr. Shore's works in the academics has resulted more than 75 publications and several US patents, all in the area of wireless and wired network. He has 13 issued US patents and several pending US patents to his credit. Dr. Shore also serves as the editorial board of IEEE Internet of Things Journal and Springer's Journal of Wireless Network. For his contribution in the area of communication network, Dr. Shore was elected as a fellow of the Indian National Academy of Engineering in 2007. Dr. Shore was recognized by ACM as a distinguished scientist in December 2014. He also recently in 2021 elected as a fellow of Institution of Engineering and Technology, UK. Currently, sir is a member of, member of ACM Executive Council of India, and in the past he was the member of Executive Committee of IEEE Communication Society Delhi chapter. With all this, Dr. Rajiv sir is also the co-founder of Chi Square Analytics, founder member of top conferences in India. I welcome you once again, sir. Today, sir will enlighten us on the topic of current trends and future direction in autonomous smart driving. Now, I request Dr. Raju Shore, sir, to take over the session. Over to you, sir.
Thank you very much. I hope I'm audible.
Yes, sir.
Okay, I'm going to share the screen now. I'm going to start the talk. Just give me a minute, please.
Okay,
yeah, I hope my screen is visible to all.
Yes, sir. It is visible.
Okay.
Yes.
Great. I hope it's full screen, right? Can you see the full screen?
Yes, sir. Full screen.
Okay, great. And also a very good morning to all. I must, extend my special thanks, immense thanks to the organizing committee of this faculty development program, FDP. And I know that Yashwant Rao Chavan College of Engineering is doing some wonderful work, right? And this FDP is very important in today's times. I think this is a great forum for folks in academia to really pick up, to collaborate, explore potential collaboration, and also to, come to know about various areas. Technology is exploding, as you all know. So I think it's a great opportunity for all the faculty members, not only in YCCE, but even outside YCCE, to understand what's happening in the space, both from the academic point of view, as well as from the industry point of view, right? So again, my sincere thanks to the organizers for your very kind invitation that I accepted. It's always a pleasure to talk to our faculty members all across the country, not only across the country, but even across the globe, and to share my thoughts. But as I mentioned to Dr. Rat Kantiwar over email, that I will take you through a journey, a very exciting journey today of autonomous, autonomous driving, smart driving, as they call it. So we'll look at the fundamentals of this area. And I think one of the important points that I like to cover today in the talk today is to throw open research challenges. See, it's very important for all of us, researchers, faculty members, be it in institutions like yours, or be it in R&D labs in industry, or be it startups. We really need to figure out what are the open research challenges that will keep us busy for a long time. So it will be my endeavor to take you through a lot of open research areas as we go in the talk. So I think my plan is to really talk for about an hour and a half, and leave the last 30 minutes open to Q&A, if that's okay with all of you, because let's make this very interactive so that it really benefits all our colleagues who are attending the FDP. So let me come straight to the talk. But before I do that, thanks to the organizer for this wonderful memento that I got. I guess all of you can see that. It's a beautiful memento from YCCE. Thank you so much. All right, I'm going to keep it right over here on the side.
Yes, sir.
Okay, so my title of the talk is Current Trends and Future Directions in Autonomous Smart Driving. Very interesting. Just this morning when I was coming to IIT Delhi from my residence in Gurgaon, I read a very interesting article, none other than the paper Times of India, which I'm going to come to what it covered. And I was really amazed. I was really amazed, and I was a bit surprised that they're covering some interesting hot areas in the whole autonomous driving, just as I was about to get ready for the talk. So I'll come to what the summary of the article is. But let me quickly take you through the journey today of my, the agenda of my talk today, right? So I'm going to start with what smart cars are and what is autonomous driving. There's a lot of buzz, as you know, we've been reading every day about the gentleman, and I think all of us know him, right? So this gentleman who's trying to take over Tesla, trying to take over Twitter. Who doesn't know our man, the founder of Tesla, and now trying to take over Twitter, Elon Musk. And every time you read about Elon Musk, the first thing that you will realize is that he is the man behind Tesla. He's a person behind your space shuttle, which now NASA has handed over to many private companies, right? So we'll talk a lot about Tesla in the course of the talk today. But let's first understand what are smart cars and what is autonomous driving, right? Let's kind of go deeper into that because I think a lot of this is covered at a very high level, but let's go deeper now since we are all researchers. And then I'll talk about the levels of driving automation. A very important concept in the whole autonomous driving is vehicular networks. I remember way back when I was in General Motors, both in Bangalore and Detroit, we were the first company, that is General Motors, to partner with Carnegie Mellon, right, and another top university in the US to come out with what is called a smart car. Google was much later ahead. Google was much later in the game. But the first few companies and universities that really started the work in smart driving was General Motors in partnership with Carnegie Mellon in US. And they then came out with the whole concept of V2X, vehicle to vehicle communications, vehicle to infrastructure communications. So we look at the whole V2X space. I'll tell you what X is. But we also look at what's inside the car. What are these in-vehicular networks? How does the network inside the car look like? And what are the various components and how do they communicate with each other? And what are the various architectures inside the car, right? So there are two worlds over here. There's a world inside the car and there's a world between, which connects the multiple cars. That's called the in-vehicular, that's called the inter-vehicular communication, right? Not intra, that's V2X communication. Then we look at the key connectivity requirements of autonomous driving. As I said, one of the most important aspects of my talk is going to be research challenges. And I think what I will do is in every slide, I'll try to share the research challenges, whether it's architectures, whether it's protocols, whether it's cybersecurity. By the way, that's the very, very important topic, cybersecurity in the autonomous sector, particularly in smart driving context. And I think that will lead me to a very important topic, which is the topic of the day, and that is autonomous and cognitive systems, right? A lot of the smart driving, smart cars and autonomous driving is driven by advances in machine learning and AI. And that is leading to what we are seeing as autonomous and cognitive systems. But I think it's only appropriate for me to share with all of you some of the startups in the forefront of autonomous vehicle technology, who's doing what. I'm very happy to know that there are a lot of now Indian companies, service providers who are now beginning to look at the automotive sector and autonomous driving. So India is now one of the as you know, one of the most important destinations worldwide for technology and services. And we'll see what we are doing in this area. And finally, we look at the trend shaping the automotive sector by 2030. What's the future of this sector in the next 10 years, right? Or the next 15 years? And finally, my concluding remarks. All right. So as you see, I'm covering a wide range of topics in autonomous driving, but I'm also going to go deep into these topics. So it's not only the breadth that I'll cover, I'll also cover the depth. So you really have a deeper perspective across the spectrum. Now, I'm going to request the audience to please ask any questions. If you have any questions, to please raise your questions in the chat box, or you can raise your hands. I'll be happy to answer any question, but I am keeping the last 20-30 minutes for Q&A. So please write down whatever questions you have. I'll be happy to address them either between the talk or at the end of the talk. All right. So please don't shy from asking questions because honestly, the whole FDP is meant for you. You are the target audience, right? And it's important that you understand the concept, which is a very important topic that I'm covering today. All right. Let me start with this whole global trend. What's happening across the world? Well, one of the things we learned being in R&D labs and of course also being in academia is that we must know what is the trend in this sector, right? What's the growth in terms of investment and growth in the sector? I'm not surprised that when you read that the global autonomous car market has reached a value of almost $1 trillion, not yet trillion, but almost $1 trillion, right? 818 was in 2019, $818 billion, but now it's almost $1 trillion. Okay, it's increasing at a CAGR of almost 12 to 14% since 2015. But the market is expected to recover and grow at a CAGR of even more, right? And reach, as I said, it'll cross $1 trillion in as early as next year. Not surprising at all, as you can see the wonderful growth of the Tesla car, which is by coming to India, has already now made its entry into India. The market is also expected to reach almost 1.6 trillion in 2025, right? And by the time you touch 2030, we're talking about almost 3 trillion. It's just unbelievable, right? Just unbelievable. That's the developments happening in this sector. which is growing very rapidly and very exponential. Now, why are we seeing growth in this sector? What's the fundamental reason? The reason is that cars are becoming more and more smarter. We look at what smartness means, because now everybody's talking about smart home, smart cars, smart office, smart transportation, right? But let's go deeper into what we mean by that, right? So one reason why there's a major growth in the sector is that cars are, the whole transportation is becoming more intelligent. It's called intelligent transportation systems. Number two, there is more and more of entertainment and infotainment. So if you look at a smart car or a nice high-end car, there's a lot of infotainment and entertainment in the car. Third thing is cars are becoming, you must have heard of the concept called automatic cruise control, right? You really want to hand over the functions to the, to the system, to the server as much as possible. I don't think that drivers, that there'll be cars without drivers. I mean, yes, Tesla, of course, is called a driverless car. But my view is that there will always be drivers behind the wheel, because driving, as you all know, is an experience, right? And nobody wants to really, I mean, people who love driving, they just love driving cars, right? I don't think that will ever be done away with. But so I think what we'll see is the conglomeration, the convergence of automation as well as drivers sitting at the wheel and trying to negotiate and trying to maneuver the car in a very simple and less complex manner, right? So there are various reasons why this sector is growing very aggressively, okay? Let's take a look at, let me just, let's take a look at this whole journey of smart cars, okay? So let's kind of understand first, what are smart cars, right? So way back when I was in General Motors, I remember that they used to use this word ECS a lot, right? And I used to wonder, what is this ECS? Of course, took us not much time to figure out that ECS is nothing but electronics, controls, and software. Today's cars, and I'm talking about the smart cars, they are smart because they are dominated by electronics in the car. And also, of course, the wireless protocols between the cars, and I'll come to that. The cars are also smart because they have controls all over the car. Right? Control means you have a closed loop feedback, right? So when you do something, when a component of the car does something, there's a feedback, right? For example, let's say you press the brakes. How well are you pressing the brakes? Is it too hard? How swiftly are you turning the wheel? Is it too abrupt, right? So you get a feedback, right? And that's the controls part of the car, which keeps everything going smoothly and nicely. And finally, of course, not surprising, the software part, right? Everything is software driven now. In fact, the whole world is software driven. You're aware of software defined networks, right? SDNs are a very important component of the whole 5G world, which I'll come to in about 5-10 minutes. But the whole 5G communication or 5G paradigm talks about the dominance of software defined networks, okay? So a smart car has tons of sensors and actuators, which you can see on the top figure, on the top left. And these sensors and actuators range all the way from tire pressure monitor to fuel gauge monitor, to automatic cruise control, to, of course, GPS is obviously there now. That's a given since quite some time. But there are all kinds of sensors and actuators in the car. By the way, the numbers could be hundreds, right? So not surprising, as the cars become smarter and smarter, the number of sensors are getting more and more complex and more smarter, right? So that's the inside of the car, right? But if you look at between the cars, if you look at intervehicular communication, right, you're seeing that cars can now communicate, broadcast, DSRC signals, I think at 5.9 gigahertz. That's a DSRC protocol. We'll come to that. Dedicated short-range communications. And they can try to communicate with each other. Basically, they're trying to exchange messages using broadcast. Why broadcast? Because this is an all wireless network. And so you really don't have any business case for unicast. So you're going to broadcast, right? And of course, finally, if you look at the car even further in some detail, you'll find that cars also have radars and lidars. Why do they have? What are lidars? Lidars are laser-induced detection, right? So lidar, L is laser. So laser-induced detection and ranging, right? So the laser beams are very focused, right? As you know, radars can cover probably a cone of feasible direction, but lidar is much more focused. It's much more concentrated. And you have now lidars and radars all along the car, in the front, at the back, on the sides. Why do you need them? Well, because you need to figure out who your nearest neighbors are, what's the distance. You want to really automate all that, right? And that's what I call closed loop flow control, right? But an important observation is that all these radars and LiDARs, they're expensive. They're not cheap. They can come anywhere between $50 to $100 per LiDAR. So remember, that's the reason why smart cars are getting to be very expensive, because all these equipments are very expensive. I can share with you an interesting anecdote. This was when I was in General Motors almost 10 years ago. And I remember meeting the vice president, the then vice president of research worldwide, a very sharp gentleman by name, Dr. Alan Taub. And Alan is a very, very sharp guy. He came from MIT and was heading the GM research worldwide, including the Bangalore labs. And I used to meet Alan at least 4 times a year in his office in Detroit. So once when I met him, I said, we have an idea to retrofit a car with a small device, a small sensor, which will do the following and all. He laughed. And he said, Rajiv, do you have any idea how much is the cost of the sensor? I said, well, it's really not very costly. It's about, not more than $5 or whatever. He laughed and went to the board and said, well, be careful when you propose something to the car industry, saying it's cheap, it's only $1 to $5, because we multiply that by the number of cars that we produce, and that's about millions per year. So multiply 5 by the million cars per year, and there you are, and multiply that by the number of cars we produce all over the globe. You're talking about hundreds of millions of dollars, and who's going to put that money? And so obviously the idea was thrown in the dustbin, right? So the whole point is that this sector is very, very sensitive to cost. Anything you do in this sector, whether it's upgrading a software or adding a new component, you really have to be conscious of the costs. Anyway, to summarize this slide, today's cars, the smart cars, are completely, they're full of electronics, controls, and they're driven by software. And that word ECS is something that you should not forget, okay? It's a very important acronym for a smart car. So when somebody asks you what a smart car is, you can now answer the question. They're not smart because they are, the design is beautiful or they look very sleek. No. They're smart because they are completely dominated by electronics, controls, and software. Okay, so that's the definition of a smart car. And of course, throw in a plethora of sensors and actuators, throw in all kinds of architecture in the car that I'll come to, and that of course also makes life very interesting. All right, let's go to the next slide. Okay. So what were the development that changed this sector forever? I remember there was some, sometimes you see technology which changes the whole game, right? For example, when people started Amazon, when the founders, Jeff Bezos and colleagues started Amazon, or when Flipkart, Sachin Bansal and others started Flipkart, it just changed the game in India, right? Or look at folks who started Tesla, for example. It just changed the whole business in this sector. So what, in my view, are the developments that change the automotive sector landscape forever? And I'm glad to share that with you. I'm also glad because I work in these sectors and with these companies. The first thing that I believe changed the game completely was what we see as the GM OnStar system. Now let's look at the slide very carefully. This is go back 15 years ago, right? I'm actually even more than that, but 15 to 17 years ago. Yeah, 15 years ballpark. If you look at 15 years ago, you find the advent of General Motors OnStar. OnStar is a subsidiary of General Motors, okay? So it's a subsidiary company of General Motors. Look at the idea that they have. And I'm telling you, those people who really founded or who were the people behind OnStar, they became celebrities across the globe overnight. Look at what they did. So the idea was very simple. I have millions of cars on the road, but so do we have cell phones, right? So there are millions and billions of cell phones all over the globe. Now, cars are autonomous. They don't really communicate with anyone. Cars are really, in that sense, they're kind of a closed door, a closed system. But if you look at a cell phone, all the cell phones by definition communicate with the base station, right? Otherwise, you really cannot communicate with any of the destination party, right? So base station is a given in any cell phone. So there's a transmitter, goes to the base station, goes to base station controller, goes to mobile switching center, and finally the same thing happens at the receiver end until you go to the destination mobile or a landline, right? Look at what OnStar said, and look at onstar.com. So I strongly encourage all of you to go to the website called onstar.com, ONSTAR.com. Idea was brilliant. let's marry the automotive sector and the cellular sector, which means if every car can communicate with the base station, how do you do that? Well, how does a car communicate with the base station? Answer is very simple. Well, just have a handshake between the automotive sector and the telecom sector, right? So look at what GM did. GM went to the biggest telecom service provider in US called Verizon. And they said, guys, let's shake hands. Ladies and gentlemen, let's shake hands. Okay, which really means that when Verizon partners with General Motors, Verizon is a telecom service provider which enables cell phones, then every car will have a dashboard which will, over the cellular channel, which you can see here, communicate with the base station, which is owned by Verizon. Which means that now a car is to be seen, much more than a cell phone, because you can have all kinds of services in the car, all kinds of new services. Let me give an example. You can have automatic crash response, stolen vehicle assistance, turn-by-turn navigation, roadside assistance. You can now, in today's world, in the US and Canada and parts of Europe and even China now, OnStar is all over. You can open the door of a car remotely. Let's say your door is jammed and you're not able to open it, right? You just give a call. You just call up the OnStar command center, say, hi, this is Rajiv calling from the OnStar. OnStar, I'm the subscriber. My name is this, my ID is this. And they'll, of course, verify you, send you all the two-way authentication or whatever it is. Boom, the door will open in no time, in fraction of a second, millisecond, right? You can close the door, you can open the door, you can start the engine if the engine doesn't start. Of course, you can't drive the car remotely. That doesn't make sense, right? One of my favorite services in the car is stolen vehicle assistance, right? Which really means that if a car is stolen, right, and which is very common in India, right, or all over the globe, you can call up the OnStar command center and tell them to immediately take action. And what they do is they send a jamming signal from the base station, from the command center base station to the car. The car comes to a screeching halt and there's a police waiting to arrest the thief. Stolen vehicle assistance is a very, very important service which has saved millions and millions of dollars in US and that region, only because they kind of conserve costs, right? So all kinds of services were enabled in the car thanks to OnStar.com. And in my view, this was one of the game changers in the world of the automotive sector. It's just unbelievable. By the way, if you look at OnStar.com, you will also realize that one of the most complicated services is diagnostics and prognostics. You can now, before you go to a dealer, so all of us give our cars for servicing, right? And when you go to a service center, you don't even know what's happening, right? Honestly, you have no idea because they don't invite you. You can't go inside the garage naturally, right? You can just keep waiting outside. So what they do is the OnStar diagnostics and prognostics, through sensors and actuators, they can monitor the health of the entire car. And by the time you go to the dealer, it's unbelievably complicated. You have the entire health of the car at your, on paper that will be shared with you by the dealer. So even before you go to the dealer, you can have an idea of what's wrong with the car. And of course, while it's with the dealer undergoing service, you have a lot more information because this diagnostics and prognostics is a service in OnStar, right? It's all big data analytics, nothing but big data analytics. So it's amazing what's happening in the automotive sector. Does India have this now? No, India does not have these complicated services. The reason is that, the reason now, because this sector is very, very sensitive to cost, right? Even if you increase the cost by, let's say, 500 rupees or 1,000 rupees, the user will say, no, we don't want that cost. India is a very, very cost conscious market. So I think, but on the other hand, it's a matter of time when you'll find all these fancy services that will happen in India. But remember, to have these fancy services, you need to partner with a telecom service provider like Reliance Jio or Airtel or Tata Communications or any or Vodafone, right? You need to really partner with them. You can't do this alone. So that's the need of the day, to partner. Okay. So that's one of the game changers in the sector. I remember in 2007, 2008, General Motors came out with DARPA, as you all know, the funding agency in the United States. They announced the DARPA Grand Challenge. And what is the DARPA Grand Challenge? The whole idea was to experiment with the autonomous driving. So what GM did was partner with Carnegie Mellon, right? And that's the another lesson that we have learned over the years, over the decades, that if universities want to do well, they must partner with industry. I'm saying this to every media I talk to. In fact, the other day we had a panel discussion, which was, I think, shared a lot of times that I come to TV channels or newspapers, or any media channel. I tell them that, look, it is critical to partner, for industry to partner with academia and vice versa. And look at what happens. One example is in front of you. GM partnered with Carnegie Mellon. They announced that they will participate in the DARPA Grand Challenge. This was a race, completely autonomous driving. There was no driver in the car. Of course, there was a driver, but he didn't. She or she was just sitting over there. The car was running by itself thanks to all these sensors, actuators, and DSRC protocol and all that, right? And all the cameras, the vision cameras, the LiDARs, the radars. It was a very expensive car. The car was called the GM Boss. And the race was, I think it was 60 miles long in Southern California. Many universities in partnership with the OEMs, that's the equipment manufacturers, the car manufacturers, participated in the race. But interestingly, GM and Carnegie Mellon won the race and they got $2 million at that point in time. So imagine 2007, we're talking about. GM, Carnegie Mellon won the DARPA Grand Challenge. They won $2 million. This car that you see in front of you is called the Boss. Just do a YouTube search, the Boss GM CMU, and you'll get actually beautiful video clips of this car that has done wonders. So that's the beginning of autonomous driving. It's actually 2006, 2007. Google, of course, announced everything much later on. But now you can see the origins of smart driving was not Google or not Tesla. It was actually GM and Carnegie Mellon and other automotive companies that also got the second and third prize. So, well, then what happened was around the same time, I think 2009, I remember, 9 or 10, something very funny happened. And something very scary happened, right? And that was the first cyber attack in the car. Please remember, as I said in the first few slides, all smart cars are dominated by electronics, controls, and software, ECS, right? I'm sure you'll never forget that. As cars get more and more, as they have more and more dominance of electronic controls and software, not surprising at all that there will be tons of attack vectors, right? Your attack vector will increase with each passing day because you have software which is very complicated. You have control which can be hacked. You have electronics which can, of course, be hacked. You know that very well, right? All devices can be hacked. But what changed the game was that two very sharp young folks who were hackers, their name was Charlie Miller. So just do a Google search, Charlie Miller and Chris Valasek. And I'm very happy. I happened to meet them in Detroit in one of the conferences. In fact, we heard them live and I was chatting with them. So the two gentlemen who were hackers and who had their own company was Chris Valasek and Charlie Miller. Look what they did. They were sitting 1 kilometer apart on their laptop and over the Wi-Fi channel. And by the way, every smart car has a Wi-Fi port, right? So it has a Wi-Fi port naturally because you want to connect with even your devices within the car. These gentlemen, Valasek and Charlie Miller, sitting 1 kilometer away on their laptop, could enter the system of a smart car. It was Jeep Cherokee by the famous, right? I'll come to the details in the next slide. And they could turn the car turned turtle. So when they did that many times, it was a headline news in the newspapers next morning that Valasek and Miller, they have, they have played with the ECS and the car is completely turned. I mean, nobody died, fortunately. But this then created a whole new Pandora's box. And this was what happened. So the company was Fiat Chrysler. It was earlier called Daimler Chrysler and then became Fiat Chrysler. And Fiat Chrysler produces cars called the Jeep Cherokee. This is what you see over here, the Jeep Cherokee car. Imagine a car on the road suddenly turning upside down thanks to some hacker sitting miles away. This was unbelievable. And so the consequence of this was that I think in an year or two after that, there was an emergency meeting called by the then President Obama in the White House. President Obama called every car company in the US to White House, every CEO to the White House and said, look, it is critical that we have a chief security officer in every OEM, that is the equipment manufacturer, right? and so be it. Today, there is no car company, including Tata Motors, including Mahindra and Mahindra. There is no car company which does not have a chief security officer. Why? Because cybersecurity has become one of the most important areas of research in the automotive sector, right? Now, you can imagine the consequences when Chrysler recalled 1.4 million vehicles. Look at the loss to the company, right? They had to recall, fix the software bug, send it back to the customers. And it turned out that that took a lot of time, of course. But, it's not about the time. It's about the revenue loss because of the reputation hit that the company takes, right? So this was another thing that changed the game. And therefore, cybersecurity became one of the most important topics in automotive sector. Okay. Okay. Then, of course, as years passed, we saw the advent of this famous company Tesla, and you all know the man behind it, none other than the gentleman by name Elon Musk, right? So very interesting that this Tesla was one of the first experiences with the autonomous driving, right? I mean, earlier you had hybrid vehicles, you had semi-autonomous vehicles, but now you really had autonomous driving practiced to the hilt thanks to Tesla. So Tesla is, by the way, all over the US now. You can see it on the road, mostly in the California Bay Area, mostly in the rich states like California, New York, and other places. Of course, California is full of Teslas. They're costly. They cost about, I think the starting cost is about $50,000, which is not cheap by any standards. But it's a wonderful car, which is completely controlled by ECS. It's driverless, which means you can sit at the back, enjoy. But of course, you have to be at the controls because you just can't be sleeping and expect everything will be done in an automated manner. I think one of the lessons learned from Tesla, one important lesson learned is that the whole area of human-machine interaction is a very important area, right? What is the interaction between completely automated autonomous systems and humans, in this case, drivers, right? How do they interact? How do they collaborate? That HMI is becoming a very important area, okay? And I'll give you some examples that they are now designing algorithms. Ever since Tesla started, there've been major research in algorithms which not only do things in an automated manner or in an autonomous manner, thanks to AI and ML, but also that have, because look, there'll always be a driver, right? So there has to be a manual aspect, manual intervention, right? How do these two systems, the manual and automated, how do they coexist? It's a very hard area of research. Please take a look at research by people such as our good friends, Professor Rahul Mangaram. Rahul Mangaram is a young dynamic faculty at the University of Pennsylvania in the US. You just do a Google search on Rahul Mangaram, you'll get some great papers. He's doing a lot of work in this area. You can take a look at papers by Adrian Perig, who was in CMU, but now he's in Switzerland, EPFL and ETH in Switzerland. A lot of great researchers working in the area. India is beginning to see research in this area. I think we are a long way, but I think we are beginning to see that. So the moral of the story is that the area is exploding from all dimensions, and great time to work in this area. Great time for people such as you in academia to collaborate with startups, to work with industries, and to solve their fundamental problems, right? Something like what we did almost 10 to 14 years ago. Okay. Now let's go to autonomous driving. So now when you look at autonomous driving, you find that you just can't work on autonomous driving without defining what are the levels of automation, without some standards, right? Technical standards, like what IEEE does or what ACM does or what, all these IETF does, right? In internet. Good news is that we have standards which define the levels of driving automation. And that standard is called the SAE J3016. What is SAE? SAE stands for Society for Automotive Engineering. Okay, so the whole automotive engineering work is done in the society SAE. It's a standard for smart car or autonomous driving. And not surprising, you'll find that level 0 means there's completely manual. There's no element of any automation. As you go to level 1, level 2, 3, 4, 5, you're seeing that there's more and more sophistication, right? So, which means that you're getting more and more. There are more and more features that you're adding that is enabling, autonomous driving. So, automated driving features are being introduced as you go from 2 to 3 and to 4 and 5. 5 is completely autonomous driving, right? This slide is important because it tells you that when you want to work in this area, you need standards. You can't just put your own arbitrary algorithm, right, or protocol. Nobody will buy it. Please remember that. You may be the smartest faculty member in the country, but if you propose something in this sector to car companies, they'll laugh because they'll say, are you following the standard? If you say, yes, I'm following the standard, excellent. That's good news. If you're not, nobody's going to buy your solution or approach. Because remember, interoperability is one of the key mantras in the sector, because look, all the cars are going to talk to each other, right? Or they're going to be similar, right? Whether it's a Nissan car or GM car or Tata car or Mahindra and Mahindra, right? At the end of the day, all of them are going to communicate with each other. Doesn't matter what the manufacturer is. And so they're similar in many levels, although there'll be differences as you go from one manufacturer to another. So good news, the standards in every layer, standards even defines the levels of driving automation. What are now some of the enabling technologies and services for smart autonomous driving? So let's look at some of the tech. Let's go deeper now. Let's look at technologies which enable smart or autonomous driving. Right? I'm going to use the word smart and autonomous interchangeably. So let's look at what they are. Interesting. So there are two categories over here. But let me stop over here for a minute. Are there any questions from anyone at this point in time before I go deeper now into technologies that enable both intervehicular and intravehicular? Are there any questions from anyone in the audience? Any questions at this point in time?
No, sir, not yet.
Okay, anyway, you can park your questions for the last half an hour.
I'm going to... so nice that everyone is busy with listening it carefully.
Yes, no problem. But do ask in the last 30 minutes.
Yeah,
I'm going to
definitely, sir.
Give a lot of time for Q&A.
Yes. If someone posts something, I'll definitely let you know.
Certainly. Yeah, please stop me anytime.
Yeah.
All right. So let's look at, let's go deeper into what these vehicular networks are. Again, this area began almost 10, 15 years ago. India is now beginning to see work in this area, but I think we've been pretty slow in this area because we don't really as such, have these fancy services like what you see in OnStar. But I think it's beginning to happen now. Two kinds of networks. Networks where a vehicle talks to the other vehicle. Now, when I say talk, I mean broadcast. It communicates. It doesn't talk. It communicates with other vehicles. Look at the figure on the top right? So cars can talk to each other, or they can broadcast messages with each other. And that's called V2V communication, vehicle-to-vehicle communications, right? Number one. Vehicle can talk to or communicate with the infrastructure, like your signal, roadside signals, right? You have the signal in any intersection, right? That's called infrastructure. So that's called V2I. Maybe cars can talk to pedestrians. That's called V2P. Maybe cars can talk to a network like a cloud. That's called V2N. So put all these together, we call it V2X. X can be now V or I or P, which is pedestrians, or N, which is network, right? So that's the whole world of V2X networks. And then you have the world inside the car. That's called the in-vehicular networks, right? You'll be surprised if I tell you that the world inside the car is a very complex world. It's just like an Ethernet inside your university, right? So you have all wire, earlier you had Ethernet, but now you have Wi-Fi all over the campus, right? So it's just like this complex network which you deploy in your industry, in your office, or in your university. Inside a car is very complicated. I mean, you may not know that, but it is full of CAN buses, FlexRay buses, electrical control units called ECUs, gateways, and therefore there are a plethora of systems within the car. And therefore, don't be surprised if I tell you in the next few slides, cybersecurity, therefore, is a very important area in this sector. The other thing I want to mention to you was there's, of course, also an interface in the car which carries traffic from within the car to the outside world. Outside world could be the other car. It could be roadside unit. It could be a base station. It could be anywhere, right? And that channel, that pipe is called over the air interface, OTA. So the entire traffic in the car, it could be petabytes, could be zettabytes or whatever. Let's say it's gigabytes or petabytes. If you have to do diagnostics and prognostics, let's say you have a lot of, as I mentioned, you have a lot of services in the car. You have sensors and actuators which collect data. If you add that data, it becomes a humongous amount of data of the order of petabytes. And therefore, not surprising, you have to do big data analytics to make meaning out of the data, right? To infer whether the car is okay, whether it's functioning, theek hai, kharab hai, engine theek hai, kharab hai, air conditioning is okay or not. And all that is done by, or you can predict the future, right? What's the probability the car will go down in the next maybe few months or next 24 hours or whatever, next one quarter. So over the interface is very important. That's a wireless channel which helps you communicate from one car to the other systems. Could be a car, could be the traffic signals, could be the base station, could be the roadside units, right? So two worlds over here, in vehicular, inside the car, inter-vehicular. Okay, let's start with in vehicular networks. Not surprising, huh? The world inside the car is fairly complicated. This is a smart car. It's not every car. Okay, I'm talking about a smart car. So how do you define smart cars? Now you know the definition, right? So here is a high-level figure, and then go deeper. This is what you see inside the car. There are all kinds of CAN buses. Look at the figure at the bottom. This is a CAN bus. What is CAN? CAN is controller area network. A CAN bus enables communication between one ECU to the other ECU. All the boxes you see are ECUs, electrical control units. They're called ECUs. Okay. And how do they communicate? Through the CAN bus, just like Ethernet, right? There are different ECUs for different functionalities. So for example, there could be an ECU for HVAC, the air conditioning and heating system. There could be ECU for engine. Engine is called powertrain. So there could be separate ECUs for powertrain. There could be separate ECUs for example, your seat belts and all kinds of things. So there's a CAN bus dedicated for each functionality. And that CAN bus has many ECUs. Did you know? You'll be shocked if I tell you this. And I myself didn't know till I used to work in R&D of General Motors. As you know that these cars are driven by electronic controls and software, any guesses how many lines of code sits inside each ECU? Each box you see over here, yellow or green, is an electrical control unit, right? Whether it's ECU for air conditioning or anti-lock brakes, or engine control, or power seats or power windows, right? Each ECU, any guesses how many lines of code? I don't think you'll be able to get hundreds of millions of lines of code. Hundreds of millions of lines of code sit inside each ECU. God forbid if the code is not written properly, or if it is not thoroughly verified or validated, you are in deep trouble, right? So this sector is also called not just real time. Of course, this is a real time system, right? Because you are in a car. It's not just time critical, it's life critical. One error in the code, let's say you have an array index out of bounds, or let's say you have a buffer overflow. Just imagine the consequences of a simple error like a buffer overflow in the code sitting inside the ECU on the CAN bus. It can be a crash which is fatal, right? So these systems like aircrafts are called life critical systems. You cannot make a mistake. And I can tell you one thing, those who work in software in this area I mean in the automotive area or the aerospace area, like Boeing or like Airbus, these people spend years and years trying to validate and verify the software. The verification and validation of the software sitting inside these systems can take years and years of people who are PhDs and spend decades working on the area. Okay, I can tell you, my former colleagues like Professor S. Ramesh, who's now in Detroit, I think he must have worked for decades in the whole area of verification and validation of distributed software. Now, this software is distributed, right? It's across different systems sitting in the car. So what's the moral of the story? That the in-vehicular networks are fairly complicated, plethora of challenges, whether it's verification, validation, cybersecurity is also a big challenge. It's a distributed system. So all the issues that you saw in a distributed system are going to be applied over here. Look at the components in the car now. Then let's name some components, right? You have ECUs, which you know what you are. You have gateways, you have compute platforms, right? You have one gateway which will aggregate traffic from all the ECUs. You have wireless networks, you have wired networks, you have OBD ports, you have GPS receiver, you have onboard vehicle networks. Like, as I said, there's a CAN bus. But the future bus will be called FlexRay. The future CAN will be called FlexRay, much more advanced, state of the art. The earlier buses were called LIN buses, right? The LIN became CAN, and now the next generation will be FlexRay buses, right? So you can see all kinds of technologies and components within the car. And so cybersecurity, not surprising, it becomes crucial, right? So in wireless, you can have all kinds of wireless. You can have Wi-Fi. You do have Wi-Fi. You have Bluetooth. You have DSRC. DSRC is basically car-to-car communication. It's a protocol which is the IEEE 802.11p protocol. called dedicated short-range communications. And then that protocol, you're broadcasting, every car is broadcasting to every other neighboring vehicle every 100 milliseconds. And that happens through the DSRC protocol. I now know that the folks in autonomous driving and smart cars are talking about 5G now. They are now implementing 5G in the cars. Now 6G is coming, just no end to the technology, right? Just no end to that. So this is the world of in-vehicular networks. Let's look at the V2X world, that is vehicle to everything. And we call it capabilities for fully autonomous driving. So the V2X world could be V2V, it could be V2 pedestrian, it could be V2 infrastructure, it could be V2 network, right? And so the entire space, therefore, is called V2X. All right, good news. Let me come back to this later. Let me start with this figure first. Right. So if you look at typically cars on the road, I'm just taking a snapshot of the road, right? If you look at the cars on the road, you will find that it's not a random motion, right? The cars really go on a fairly streamlined motion. I mean, they seldom move zigzag, right? So the good news is the motion is very well defined. It's rectilinear. Of course, there are turns and, you have all kinds of circles and turns and so on and so forth. But by and large, the movement of cars on the road is structured. It's not random Brownian motion, right? It's structured. That's good news, right? Now, when a car has to communicate with the neighboring vehicles, why neighboring? Because I don't care about the vehicles that are not my neighbors, right? But they won't collide with me, right? I'll probably only worry about my nearest neighbor, right? Because that's where the collision can happen. Why should I worry about cars that are 1 mile apart? Who cares? How do I communicate? I would broadcast every periodic second or millisecond or whatever. I'll come to the numbers. I'm going to broadcast every 100 milliseconds. So all my neighbors in my transmission radius will get my message. So let's take an example. Let's take the red car. The red car has the black car as its neighbor in the transmission radius. Also, the blue car is a neighbor, right? So when the red car broadcasts a message, that message could be a safety message. We'll come to that. Who is going to hear? The blue and the black car, not the green car, because the green car is not in the transmission radius of the red car, right? So the green car is not going to be affected. But the nearest neighbors will listen to that broadcast, and maybe they'll in turn broadcast, and so the red car will hear their broadcast. And that's primarily for safety messages, right? What kind of messages? All kinds of messages that you see over here. You can avoid intersection, you can avoid collision, you can have, so that's called collision mitigation. You can avoid rear-end collisions. You can have all kinds of interesting services which are going to help you to reduce the accidents on the road. And that's going to be enabled through DSRC protocol, which broadcasts every 100 milliseconds, that thereby the nearest neighbors can listen to the broadcast. They can get the broadcast, right? The good news is that if you look at now all the layers of the protocol stack, right, from the physical, all of you who've done networking, you know that networking is characterized by all these multiple layers, right? So all the way from the physical layer to the application layer, the interesting thing is that all these layers are ratified IEEE protocols. They're well-defined IEEE standards, right? Physical layer is what's called DSRC. It's called the IEEE 802.11p protocol. That's nothing but a tweak of the Wi-Fi 802.11 protocol. And I'll tell you how it's different from Wi-Fi, but it's very similar to Wi-Fi, right? Then you have the higher layers, which are 16109 layers, all the way to the application layer. An important point to note is that a very important layer called the security layer is called the 1609.4. This is so the security is provided by 1609.4. And so that's also defined. So how do they define security in this sector? They define it as a public key cryptography. So there's a PKI enabled in this sector in the autonomous driving or in smart cars. All of us have a private key. So when the cars are manufactured, they come out with a private key. Where do you get the public key from? You get it from the roadside unit, or you get it from some certifying authority sitting at the back end somewhere. So that's where you get a public key from. But the important point to note is that all the layers here are ratified IEEE standards. Therefore, you can work in this area along with your partners in industry and arrive at maybe new algorithms, new protocols, run them on a prototype in your lab, and pick up some great fundamentals in the area. Okay, this is called a WAVE protocol stack. What is WAVE? I think WAVE stands for wireless access in vehicular environments, right? wireless access, in vehicular environments, and therefore the whole stack is all the layers which are implemented in each vehicle. Okay, all right. So what are the network requirements? Let me move a bit quick because I have a lot to cover in the next 30-40 minutes. So time is very critical here because you cannot wait. It's cars real time on the highways, right? You really don't have much time beyond a few hundreds of milliseconds, right? So you can't expect to wait for a few seconds. That's too much for this sector, right? So at most you have tens of 100 milliseconds with you to take a decision. Otherwise it'll be too late, right? So timing is very critical here. But then interestingly, these are not just the real-time system, but they're also life-critical systems. And so be extremely careful about what you do over here. Now, interesting development that we're seeing is that we are seeing 5G technology and Wi-Fi technology merging now. Actually, Wi-Fi 6 and 5G are actually, they're very closely. Wi-Fi 5G defines Wi-Fi 6, which is an enabling technology. So now they are saying that let the future smart cars be completely governed by 5G, and I'll come to what 5G is in the next few slides, but also Wi-Fi. Which Wi-Fi? Wi-Fi 6, which is very high speed Wi-Fi. Maybe if you are in the campus, or maybe if you're in an indoor environment, let's say a big garage, manufacturing capability, maybe Wi-Fi is going to dominate. But when you're on the highway, of course, there'll be 5G naturally, right? So what you will see is, what you will see is that 5G and Wi-Fi 6 are going to coexist in the sector. And how they do that seamlessly is an interesting area of research. How will Wi-Fi and 6 and 5G, coexist seamlessly? That's an important area of research, right? So handovers should be very quick and soft handovers and very fast and smooth and so on and so forth. Now, let's come to what's the impact of 5G in this sector? How will 5G characterize or influence, the better word is influence the automotive sector? So if you look at this carefully, So if you look at this slide carefully, you'll see the three umbrellas under 5G. What are the three umbrellas? So 5G defines an enhanced mobile broadband. It defines a mission critical service, and it defines a massive IoT, massive Internet of Things, right? So if we look at the car will be influenced by both enhanced mobile broadband, because there's a broadband pipe from the car to maybe the back end. It will also be influenced by massive IoT, because remember, all the sensors and actuators in the car is nothing but IoT. It's going to be Internet of Things, right? All these sensors like tire pressure monitor, or sensors such as which monitor how well you drive, right? And so on and so forth, is nothing but IoT. So the 5G world is going to play a very, very important role in the automotive sector. Why? Because you will get massive bandwidth going out of the car, right? That the car wants to communicate with the infrastructure, that is road traffic signals or the other cars. You'll have huge bandwidth. You will have reliability. You will have cyber security, which probably will built in to some extent, not completely, but to some extent. So 5G is going to play an important role in the smart cars. Remember that one of the critical areas here is edge computing. And for those who have read 5G, edge computing is a critical part of 5G. So there's IoT on the one side, there's edge in the middle, and there's cloud at the end, right? And it turns out that edge will be a place where you'll do a lot of real-time processing of data, which you get from the car. I'll come to that slide in just a minute from now. Let's go ahead. And if you go deeper into 5G, you'll find that 5G, as I said in the last slide, it's characterized by these three services, right? It's a massive IoT, mission critical control, and enhanced mobile broadband. But now observe that each of these three paradigms have their own metrics, right? They're well-defined metrics. Okay, for example, enhanced mobile broadband, obviously we'll talk about massive capacity, right? Extreme capacity. Whereas massive IoT will talk about ultra low complexity and ultra low energy. Whereas mission critical control, where you have ad hoc networks, let's say something has failed in emergency, you will activate mission critical control. That'll be characterized by ultra low latency and very high reliability and strong security, right? So each service will will have their own metrics. which will play a role. And so therefore, this slide is very important for those who want to work on 5G. And now we're talking about how do we combine the V2V, which is coming through DSRC protocol, and the cellular. So remember, when I said V2V, I said V2V is enabled by the DSRC protocol. DSRC is what? Dedicated Short-Range Communications Protocol. That is 802.11p protocol. Now, you could ask, why not 5G? Why not cellular? Sure. So you can merge the two. And that's the topic of this slide. That you can have a context switch which says, under certain conditions, I will have DSRC. And then when I'm in very high speed on the road, I'll probably leverage 5G cellular channel, right? So this is also an area of research. How do you ensure that the 5G world and the DSRC world, because the different worlds, how do they, what are the convergence of these worlds? So it's kind of interesting to see what's going to happen. All right. So what is the key connectivity requirements for autonomous driving? So clearly by this time, you will appreciate that all the architectures I have must be redundant and real time. Real time, I think you've heard many times from me in the last 1 hour, right? So all the architectures must be real time. They must be redundant. I must have fault tolerance. Agar ek device fail ho gayi, so maybe I'll have another device. Good news, but it comes with a big cost, because every time I add a device, I'm going to add a cost, right? The demand for high-speed data will only increase. With time, you will find that there's more and more capacity thrown in this sector. That the sector means the automotive sector, right? Because you'll have more data from petabytes, it may go to zettabytes, and how do you handle it without very super high speed, super high bandwidth, right? Safety is critical. So how do you ensure safety? One method is V2V communication, right? That you broadcast all the neighboring vehicles, you send messages to them to slow down or to increase the speed or to not to do this or to do that, and safety is very critical. Quality and reliability are non-negotiable. In any autonomous driving, you'll find that quality and reliability are very critical. Electrified cars will require a new approach to safety, and finally, the next-gen cars will require miniaturized solution. You really need very small IoT devices as in the coming years, right? So these are all these interesting requirements that will enable autonomous driving. And there are many more. Cybersecurity is, of course, a critical requirement for both in-vehicular as well as intra-vehicular networks, right? Okay, let's move on and see some other interesting developments. Okay, so what are the, so I already mentioned that architecture must be redundant in real time. And this kind of tells you that there is a lot of research happening now in how do you ensure redundancy, how do you ensure fault tolerance as you design architectures for autonomous driving. So this is just one slide which covers that, right? I'm going to skip this slide, which just tells you that as you go from low bandwidth to very high speed, very high capacity. Look, you're going from hundreds of Mbps to almost of the order of tens and hundreds of Gbps. And these systems are called the ADAS system, right? So ADAS is going to be, the whole high speed, high capacity data is going to play a very important role. So demand for high speed data will increase with each passing year. That demand will obviously, why do you need so much capacity? Which means bandwidth, because you're providing safety, number one, you're providing infotainment and entertainment, number two, and you're communicating with all, plethora of in-vehicular networks, right? Which you saw in my previous slide. So all these reasons, you will see the growth of advanced driver assistance systems called ADAS systems in course of time, right? Which are going to be characterized by high resolution cameras all across the car. You'll have radars and laser-based radars, LiDARs. You'll have future human-machine interfaces, future HMI, maybe very fancy way that humans can, maybe I can talk to the car in the future. Take a left, do this, increase the speed by whatever amount. I don't even have to use my hands. I can just through voice communication, or maybe in future through my mind and eyes. Who knows what the world is heading to in years to come. So it's a very, very interesting world of human-machine interface. Okay, so the ADAS systems are going to play a very important role in the future. All right, what are the key challenges in autonomous driving in smart cars? The first key challenge, and I think you by this time you know this extremely well, is cyber security. Are you surprised? Shouldn't be. Look at this figure carefully. Every time you add a device or a hardware, so listen to this carefully. Every time you add a hardware or a software patch or a firmware or an operating system, or maybe a wireless new protocol in the car, you're adding to your attack vectors. Don't ever think that your Wi-Fi is safe. No, my friend, it's not safe. I can launch a Wi-Fi attack anytime I come to your place or vice versa. Don't think Bluetooth is safe. No, 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 no. Bluetooth, there are interesting attack vectors that can attack Bluetooth. Nothing is safe till you ensure that your software mitigates, takes care of those attack vectors. Okay, so remember, by default, no system or device is safe until you don't have countermeasures, which we call mitigation, so that you avoid those attacks, right? Attack vectors, because there are many categories of attacks, right? So you can have all kinds of attacks. Right? You can have man in the middle attacks. You can have attacks at the end devices. You can have privacy violation attacks. Right? For example, your car ID, somebody knows I can hack into your car, and just like what Charlie Miller and Chris Wallace did, right? You can have privacy violation attacks. You can have GPS spoofing attacks. You can have all kinds of the car key, the fob attack. You can hack the car keys, right? The remote through the NFC or the Bluetooth, right? You can hack the airbags. It's kind of a dangerous world out there. So some are, of course, low threats, some are moderate threats, some are high threats, but you can launch all kinds of attacks in this sector. That's a dangerous thing to happen, right? Until you don't work on it. And you already saw that there's so many components, each has its own vulnerability and therefore attack vectors, and you've got to solve that problem. Okay. Now, what's the answer? Well, the answer is that I must first define what all are the possible attacks, called the attack vectors, and then I must solve the problem. Good news is that there are all kinds of approaches, such as your STRIDE approach, or all kinds of mitigation. Now they're talking about fault isolation inside the car, talking about protocol conversion in the car. Now you can. So what they're saying is all the components in the car must be segregated. They must be isolated nicely. Why should air conditioning, interact with the engine? Why should engine interact with your airbags? There's no reason. They're different systems, right? So let's have fault isolation. Let's have segregation in the car. Let's have secure coding. Let the code itself be very secure through stack cookies and all kinds of these concepts. Let's encrypt the packets. Let's decrypt them at the other end. Let's do signing and verification wherever possible, right? So they're all kind of structured approach to threat modeling inside the car, which will help you solve the problem. And by the way, if you work in cybersecurity, particularly in the automotive sector, you're going to be earning huge salary, because it's a very hard area to work with. And also it's a relatively new area, right? So I think one of the things that we're conscious that there is a huge need for people in cybersecurity in the automotive sector. There are very few in the country, but I think the numbers will increase with time. And hopefully my talk here will make a difference to many of you who will, in course of time, try to explore open problems in this area. Okay. Now, you can secure your controller area network through authentication. You can have gateways that validate all the firmware. You can have analytics-driven intrusion detection, intrusion prevention system, and so on and so forth, right? So all kinds of approaches. You can secure your hardware through some concept called a trusted platform. So as you all know, there's something called a trusted computing platform, right? Which will ensure that your hardware, whatever your hardware is, secure because this platform is trusted, right? And that's a very important area of research. You can have trusted applications, trusted APIs. Don't think APIs are secure, by the way. They could be. I can launch an attack on APIs. I can explore the vulnerabilities over there. So you can also ensure that you trust the APIs and all the applications, all the software, or every code has to be trustworthy, if you will, right? So all kinds of solutions put together will make sure that your car is safe and secure. Okay, let's come to V2V. What are the possible attacks in when vehicles communicate with vehicles or when they broadcast messages, right? Tons of attacks. I can cheat you with bogus traffic information, right? I can launch an attack sharing bogus traffic information. I can disrupt a network. I can cheat with your XYZ coordinates, right? Or X.Y.Z. coordinates, acceleration, velocity, acceleration, and so on and so forth. I can give wrong information to the neighbors. I can track you, which means I'm violating your privacy. That is not acceptable in today's world, right? Imagine if somebody hacks into your cell phone and gets all your information about your friends, your family, right, and what you do. It's a disaster, right? You cannot do that. It's a privacy violation. So you can see all kinds of attacks possible even in V2X communications. Yeah. How do you solve the problem? Answer is you can solve the problem through, let's go to the next slide here. You can solve the problem through something called, so let me come back to this. So let me start. So you have all kinds of security features as you propose solutions in V2X. Now, all your nice security words that you heard, integrity, authentication, privacy, all of them are important in the vehicular context. But there's one important security property that you may not have heard. And that's called non-repudiation. I repeat, over and above message integrity and entity authentication and privacy, non-repudiation is a very important security metric in a vehicular context. What do you mean by non-repudiation? Non-repudiation means that when I receive a message, I'll be able to prove afterwards that the sender, in fact, did send the message. Let's take an example. Let's say you send me a wrong, malicious message saying, Rajiv, increase your speed. There's no problem at all. As I take a left turn, there's no problem. Go at full speed. So that's a malicious message. I double my speed and boom, I kind of, there's a collision, right? If there's a collision, I can, in fact, whoever sent me, whoever is the transmitter of the message, I can put the gentleman or the person behind bars. It's a non-bailable offense because non-repudiation is a property which enables you to prove that the sender, in fact, did send the message. It's just like your cell phone. Just like your cell phone. You send a threatening message to, let's say, Mr. XYZ or Miss XYZ, and you cannot backtrack, right? I keep telling this to students every time I meet or even to, wherever I give talks in cybersecurity conferences. Please be careful. I tell this to everyone when I talk about cybersecurity in conferences or workshops. When you send a negative message, it could be SMS, it could be a WhatsApp. All of us joke, that's fine. But in your dreams also, do not send a message which threatens anyone, because that is, from the point of view Indian Penal Code, it's a non-bailable offense. You'll be behind bars for your life. There's no bail to that offense. Okay? So please be careful. Same with the car. If you send a malicious message which will foster collisions, you are in deep trouble. You're done. And now you may say, how do I find out? Very simple. Non-repudiation. Okay. In fact, the cellular industry is already talking about, trying to pinpoint who's the originator of the WhatsApp messages that try to disrupt the society, right? All these malicious messages about all these religious nonsense, right? Trying to, send wrong messages, trying to influence people in the wrong way. Not difficult to catch them now because you can now go back to who the originator is, even though there's a complete encryption. But I think the government is now forcing that let's try to find out who's the originator of that, of the malicious message, which will disrupt the normal functioning in society. So it's a dangerous world out there. One has to be very careful not to misuse the system, whether it's a car system or it's a cell phone system. Same story. Now let's go back. The world of autonomous driving is also very complicated. The cybersecurity is very complicated because of many other reasons. These are resource-constrained platforms. You don't have infinite memory or processing power in the car. You have limited memory, limited processing power. So you're a resource-constrained platform. Whatever you propose has to scale. Your algorithm must scale. Scale means not just, they can't run for just 5 cars. They run for, all the components in all the cars, right? So they must scale. You have to deal with wireless networks. As you all probably know, wireless networks are lossy in nature, right? They're lossy. The packets are lost. The packets are dropped, no matter how strong the modulation of the coding, because these are wireless links. So you have to live with that. And finally, whatever we propose, your architecture must be interoperable. They must be able to operate within the different cars and cars of different companies and so on and so forth. The interoperability becomes a very important feature. So the key design, we call them key design drivers to enable active safety. Why active safety? Because you are providing safety on the road dynamically. It's not safety from the seat belt or your airbags. That's called passive safety. Right? Seat belt and airbags is passive safety. This is active safety. You're trying to ensure safety while moving on the road. And you're limited by all these challenges in front of you, right? In blue color. Okay, now let's go clear. And so we have realized in our decades, 1 decade worth of research, the 3 critical areas of research in the automotive sector, in the V2X space. The 3 key areas are credential management, broadcast authentication algorithms, and misbehavior detection. And I'll spend just a minute on each of these very quickly. Credential management means that where will you get the public key? So it's a PKI. Private key to hai aapke paas. Aapki gaari, when your car is manufactured, you get the private key at that time. But where will you get the public key? You'll get it from the certifying authority, right? Like VeriSign. So, but what happens if the cars are malicious? You throw them out, right? So dynamically, you have good cars coming in and you throw out the bad cars, which are malicious cars. And so you have to manage the credentials of all the cars on the road. So that's a lot of work. That's called credential management. How do you ensure that your broadcast is secure? मैंने आपको broadcast किया. सारे neighbors मेरे आसपास सबने मेरा broadcast सुना. How do you know the broadcasts are secure? Answer, well, you know they're secure because you will secure them through PKI. So go deeper. You will have elliptic curve in cryptography. You have ECC enabled in this sector. So every time I send a broadcast, I will sign the broadcast. And every time you, as my neighbor, as you receive my broadcast, you will verify the broadcast. So signing verification will happen dynamically and in real time. And they are not easy. They're kind of very complex operations. Verifying is fairly complicated, but you got to do it in real time. Real time means what? Less than 100 milliseconds. So you got to be careful. So whenever you work in this area, you have to actually have a POC, you have to have a prototype that will show, okay, yes, my algorithm works, it works correctly, it works in real time. And so you spend the next 10 years trying to convince the industry that, look, whatever you do is really correct and it's doing what it has to. And finally, the important area of research is misbehavior detection. What do you mean by that? You can't have false negatives and false positives. So you can't have type 1 errors and type 2 errors, which means you can't call a good driver a bad or malicious driver. He'll take it to the court. You can't even call a bad driver a good driver because then the damage is done, right? So you can't have false positives. You can't have false negatives. And that's the whole area of misbehavior detection. And when you do all this, you have to keep designing new algorithms, and you have to keep doing performance analysis. And also remember that this area, if you work on, who will give you these cars to try? Nobody will give you a couple of crores to test 10 cars in your campus, right? I mean, who has that money? So you'll have to start with simulation. You have to start with simple POCs in your lab. Simulation maybe in QualNet, in OpNet, in NS2, NS3. Get some interesting results in papers and now try to build a POC and then go to a car company and say, okay, look, I have learned a lot of interesting lessons. I have some interesting ideas. Now let's partner. And then they will give you their cars and pump in money in your university because they know that you're building expertise in the area. Okay. So the key lesson we have learned in our long journey, I'm going to skip all these slides. Let me come to a very important point in my talk. Yeah, so I'm going to skip all that. It's too detailed. These slides are talking about how do you do credential management, how do you do broadcast authentication, how do you do misprotection. So I'm going to skip that in the interest of time, but I'll be happy to talk to you offline. Right. So one lesson we have learned is that cybersecurity is a very critical area, and that requires a lot of expertise to understand the system, the autonomous system, the components in the car, and build a table. The table is like this, right? You have to build an attack vector table. So you're really building an attack table, attack database, which will list all kinds of attacks. What are the types of attacks? What is the description? What is the asset? What is the likelihood of the attack? What's the impact of the attack? And then you multiply the likelihood and impact. What's the risk? Risk is nothing but likelihood times impact. And finally, what is the cost of mitigation? This is not the implementation cost. What's the cost of mitigation? What will be the cost for you to propose solutions to avoid that attack? That's called mitigation. So what's the rough cost of mitigation, right? So you need to have an idea before you work with industry or if you're in industry. So you need to build this attack and defense database table to give you a better hold of the various categories of attacks in the car. When I say car, I could include trucks, I could include all kinds of cars, right? Not only cars, but even trucks and any other vehicles on the road, right? So cybersecurity is a very, very important area in the space, and which there's a lot of work going on in the world in this area. I want to skip this slide. Okay. There is a new metric now defined by the Industrial Internet Consortium called trustworthiness. What they're saying is the world, the systems are becoming so complicated, like your cars and your aircrafts and your industrial IoT systems, that security itself is not enough. Now, this is one very important slide in my talk today. You're now moving from just one metric of security to a metric called trustworthiness. And trustworthiness includes not only security, it includes security, privacy, safety, resilience, and reliability. Why all these? Well, because now you're experts, right, in the last 1.5 hours, that safety is critical in the area I'm talking about, in the cars. Privacy is critical, reliability is crucial, resilience is crucial. Okay, and all these are defined very nicely. It's not only security. Combine all these 5 and the new metric is called trustworthiness. And so in future, I'm not surprised that many of you will start looking at trustworthiness as a 5-tuple of the 5 metrics and not just one metric in isolation. Okay, so please remember that we now are talking about multiple metrics, union of them, and that metric is called trustworthiness. And that's critical when you want safety in addition to only security. But you define safety. Of course, one has to define what safety is. And there are standards for that too. Let's go forward. We are seeing the evolution. Okay, I'm going to come back to this later on, but yeah. What are the game-changing applications and services in the automotive sector? So I already mentioned about OnStar, right? OnStar.com. Please go and see the website. That really changed the game 15 years ago. Okay, when you could communicate, when a car could communicate to the back-end base station, and you could enable these tons of services. By the way, I've written only 4 here. There are many other services like diagnostics and prognostics that can be provided through OnStar. What is the other thing that happened? Well, look at the other services. So then what happened in the course of time, startups started defining better and better ideas. Here comes a usage-based insurance from a company called Progressive. So a startup called Progressive said, okay, let me define, see what happens in US and many other countries in Europe and US and that in North American subcontinent is that your insurance is very expensive. You pay $100 per month for your car insurance, right? India is also getting to be there. India is also not cheap, but it's not, India is also roughly around that much, but that's per year, but there it's per month, right? How do you reduce the insurance costs? So what this company did was a brilliant idea. They said, I'm going to give you a USB, like a fob, like a device, which you'll insert in your dash box. And that's called Snapshot. It's in front of you on the right side. This will monitor how you drive. Okay. So we drive well, and I'll come to what you mean by well and not well. If you drive, if you're a good driver, then insurance will go down. If you're a poor driver, insurance will go up. So let's say you are drunk and let's say somebody's drunk and the person is driving a car. It's not surprising the person will accelerate randomly. The person will not turn the wheel properly. Okay, all kinds of data analytics will happen. They will record your data, and that will go at the back end, and they will use big data analytics to analyze how you drive. And if they find you drive well, which means everything is smooth and nice, then the insurance goes down. If you're bad, it will go up. So this is called usage-based insurance from Progressive Insurance. And you can see how much money you will save only thanks to technology and thanks to big data analytics and AI and machine learning. So that's another example of an idea that really, was one of the fantastic ideas. And any startup that worked in this idea or this area became, these people became millionaires overnight. So that's another idea. So what we are seeing, therefore, is what's the summary? I'm going to wind up my talk in 5 minutes and open it to Q&A. The summary is that even in this sector, the smart or autonomous driving or smart cars, AI and machine learning are everywhere, everywhere. You cannot do without, they're indispensable. You cannot do without deep learning, machine learning, and AI, right? That implies that you're now seeing the advent of autonomous and cognitive systems, right? So systems that mimic the human mind, systems that mimic the human brain, right? That have all the features such as, they can come out from failures, they can repair themselves, and all kinds of wonderful features, right? Uh, the systems are, self-healing, and all these self-word that you use, right? Self-healing, they kind of improve with time. These cognitive systems and autonomous systems are happening thanks to the deep research going on in machine learning and deep learning. And not surprising, you are seeing people apply this to the automotive sector now. Now, this morning, as I was in the car coming from Gurgaon to IIT Delhi, which is about 45 minutes, very interesting, right? You open Times of India, and this is page 21 today. And the title of the item is How AI Orchestrates 4 Areas Central to Autonomous Cars. So now they're saying that there are startups in India, or the companies in India, that are looking at the companies such as, I can read them, Nagaro. There's Nagaro, one of them. There's ETCS, so on and so forth. But Nagaro is doing some good work. They are now looking at how do you, so it's really under the intelligent transportation umbrella. So you can do now localization and mapping very efficiently. You can do scene understanding around you very intelligently. You can plan a journey very nicely, right? Let's say you go to the airport and there's jam. It'll take you through all different routes, maybe longer, but at least you reach there well in time, or it'll avoid the congestion, right? Or even to figure out the internal state of the car. How's your engine doing? How are the tires doing? How's your all kinds of brakes performing? All the internal states of the car, just like what OnStar does. Can you do big data analytics and try to predict the failure in the future? So the good news is that this article is as early as this morning, right? So you can see that India is now waking up to problems, fundamental problems in the automotive sector, right? Such as what you see in front of you, right? So AI and ML are all over. And now if you go back to my previous slide, if you go back, you'll find that researchers are now applying deep topics to do, this is, so take for example, you can now estimate a channel, right? A wireless channel. You can use Bayesian learning and deep learning to do channel estimation. I remember Professor Andrea Goldsmith in Stanford is doing some great work in estimating the millimeter wave channel using deep learning and machine learning, right? So you can now estimate, you can do a channel modeling based upon machine learning and deep learning. You can do traffic flow prediction using deep learning and probabilistic models. You can do vehicle trajectory prediction with Gaussian mixture models. All kinds of research is happening in intelligent transportation systems, which wasn't happening even a few years ago, right? So let's go on and see what else is happening. This is again a recent set of work. You are now seeing the advent of edge computing. So autonomous world is now merging with the edge world. Remember, I told you that 5G is defining edge computing, right? So the edge computing is a part of 5G communications, or 5G paradigm. And so what we are saying is all these vehicles on the road in future, where will their data sit? Won't go to the cloud. Cloud is too far. It'll first go to an edge somewhere. Edge could be a base station, right? And then it will finally be stored at the cloud. Why edge? Because edge is closer to you. Edge is always closer to the IoT devices or the vehicles, right? So the processing is much faster, right? It's much faster. It's real time is critical, so it has to be faster. It's closer to you, therefore it's faster. At the end of the day, everything will go to the cloud, but you want to process it very fast. So you want to really explore the possibility of edge as much as possible. So edge computing and autonomous vehicles is a very important area of research. And what we are seeing is the whole concept of, there's a new concept, and a lot of my students in IIT Delhi are working in this area called edge intelligent systems. So you can see now that the last mile, you can see devices, and these could be cars, right? They will talk to the edges over here, and edges in turn, of course, will talk to the cloud. So the edge intelligent systems are becoming very important. We are now beginning to see a lot of research in how do you run convolutional neural networks on an edge. We are beginning to see some interesting work in federated learning. So a lot of my students over here are looking at some fundamental modeling aspects of federated learning. How do they perform when you run them on the edge? So please read federated learning. It's a very important hot area which talks about federated learning is nothing but distributed machine learning. How do you distribute machine learning across the edge nodes so that you increase the performance, you increase the efficiency, and you reduce the end-to-end latencies, right? So all kinds of features in federated learning. And as you can see that all these edge systems are characterized by these 5 metrics. There's accuracy, there is energy, there is latency, which is delays, there is memory, and there is security. And so you really have to work across all these 5 metrics if you have to work on edge intelligent systems. I want to make one final comment. If you are working on intelligent transportation system like the cars, right, which you see on the right side, you will have to look at the edge because all your data or the traffic will first go to the edge. And that's where you'll process the data. How will you process it? You'll use machine learning algorithms, you'll use deep learning, if it's video and audio or whatever, if it's images, or you use federated learning. But these are concepts. But I think the use case is very important. What is the use case? What's a business case? Okay, once you have the business case, you can always look at the relevant technologies which are going to give you some interesting answers. So the edge computing and vehicular networks are merging, autonomous systems are merging, and that's an interesting development. Tons of startups in the world in this sector, in autonomous driving. So there are a lot of, in the autonomous vehicle technology, there's startups like Optimus, which will basically give you self-driving systems or fully autonomous rides in US, or robotic rideshare vehicles, or collaborative robotic solutions, or advanced driver assistive systems, or predictive collision alerts. All kinds of startups doing fancy things thanks to my thanks to the exponential increase in machine learning, AI, deep learning, federated learning. There's another concept called MARL, M-A-R-L, multi-agent reinforcement learning. So that's another thing that we are looking at. How do you use reinforcement learning in systems like UAVs, drones, right? How can you plan the trajectory of drones using multi-agent reinforcement learning? It's called MARL, MARL. So in addition to federated learning, also pick up when you have time, the whole idea of MARL. It's a very interesting concept, right? All kinds of startups in the world looking at this space. What's going to happen 10 years from now, in the next 10 years? Well, not surprising, right? Now that you know, complete convergence, the auto industry will see all technologies converging, human machine interface, chain, digital, everything will be digitalization, will be completely digital. There'll be e-mobility, there'll be autonomous vehicles, there'll be connected vehicles. All vehicles will be connected, whether they are trucks or platooning in the trucks. I didn't even talk about platooning. When trucks talk to each other in a one-dimensional vector, when they're all going together, platooning means that one truck communicates to the truck behind and all till the last truck over wireless signals. For reasons that are well known, you want efficient navigation on the road. That's platooning. So whether it's connected vehicles or autonomous vehicles or e-mobility or new use cases or let's say a new infotainment, entertainment, or there'll be a complete digitalization of automotive industry. And in this digitalization, on the one hand, you'll have products, you'll have customers, and of course, so there'll be on the one hand, customers who are the users, there'll be manufacturers, there'll be software, there'll be service providers, and of course, there'll be folks deep into software and system software, both application software and system software. So the future of this industry is very, very exciting. It's very complicated, but it's very exciting. Anything complex, anything exciting is by definition complicated because there are too many systems and they interact with each other, right? So anyone's guess that I'm going to be seeing huge number of startups in India in the next few years in this area, right? If you have any idea, I'll be happy to discuss that offline. You will have my email ID. And of course, I'm on LinkedIn. I'm on LinkedIn and Facebook. So anytime you want to get in touch with me, you're free to send me a message. So the future looks very bright. There's no doubt about that. My concluding remarks, I really want to spend time on Q&A. It is clear that autonomous driving is changing the way we view vehicles and mobility. There's no doubt about that. What's the best example we have in front of us? Elon Musk, Tesla. Tesla is already coming to India, right? So now you will It's a matter of time when you see Teslas in Delhi and where you are, right, Nagpur, or wherever you go in big cities or tier ones, tier twos, you'll find Teslas. People who they can afford Tesla, they certainly buy Tesla. It's a beautiful car to have and to drive, and less headache. But of course, one has to be careful because you can't completely sit back and relax. You have to have the hands on the wheels so that you have some control and it's not completely automated. Three things will define the next gen cars: passenger safety, comfort, and entertainment. Right? Imagine doing a video call with 100 people in the car and the car is moving. And of course, you're really doing business in the car and you don't care about the traffic, right? So that's going to really be happening in course of time. So the world of electric vehicles and autonomous vehicles is moving very fast. And by the way, I didn't even talk about electrification. Vehicles are becoming more and more electric. So there's smart grids. Smart grid is a very hot area of research. And a lot of companies that are moving to completely electric vehicles will have to provide grids all over the country because you have to charge your vehicle periodically. Otherwise, it will not, it will not take you beyond a few hours, right? Many research challenges in this area, plenty of them. I think you already are convinced that cybersecurity is critical. How do 5G and the Wi-Fi 6 worlds converge in automotive systems? Open research area. How do you apply AI and machine learning in autonomous research area? How do you define new services and applications? I mean, maybe you'll make money. Many of you may become millionaires overnight if you define something like OnStar or progressive insurance, dynamic insurance, right? Think of some idea that will get some money in the market, right? So you'll see the emergence of connected, collaborative, and a cognitive ecosystem. So you're moving from connected to collaborative to cognitive, and that's going to change the game. Flying cars. Just the other day, I was talking to my ISC Bangalore, where I'm from, and a couple of our students are now working in California, and they're looking at flying cars. Can you imagine? Now, these cars, of course, they're not UAV, they're not drones, but they are exploring. Can humans take off right in the car? Can they take off just like a small aircraft? So these small flying cars are now, we are seeing some prototypes and POCs coming out in the US. Imagine the consequence of when you see a car in front of you, right at the bottom, figures over here, right? They're all around you, just like the Star Wars or Star Treks when we saw in a long time ago, right? I think that world is now becoming a reality. It's a dangerous world out there. Then there are major other, So in the Indian context, of course, you'll have its own problems. Our road conditions are different. We have chaotic traffic. We have obstructions. We have animals on the road. We have pedestrians crossing randomly. So I think Indians' driving conditions are very, very chaotic and very random. But also they make your work more challenging, right? So you may want to keep that in mind as you propose solutions for roads on India, right? All kinds of new services. I don't know why we are not seeing. Why is there no stolen vehicle detection service in India? I think it must come out ASAP. There's so many cars. I believe in Delhi itself, about 100 cars are stolen per day. But somebody should solve the problem through technology, right? We must explore the synergy between pervasive healthcare and autonomous driving, which really means that sensors in the car, maybe they can, if you're unwell, they will not allow you to start the car. Imagine, the world is not far that if you're unwell, if you have fever, or if you're feeling weak, the sensor will look at your eye movements, look at your various body parameters. It will not allow you to drive because you're not feeling well. So there is going to be interesting research between healthcare, pervasive healthcare, and autonomous driving. And that's another open area of research, right? It's plenty to do in that area. Then, of course, I've already mentioned deeper in technology, edge computing, cloud computing, modeling analysis is very important, right? And so on and so forth. Okay. So my last comment over here is that, which I don't think, I thought I'll mention that to you. I think it's very important to collaborate in this area, right? This is an area where collaboration is absolutely critical because look, you may be the best university or industry. You cannot work without experts across the globe, not only in India. So academia has to work with industry. Industry has to work with academia. You have to work with startups. You have to work with government of the country, where the government will define the spectrum for, let's say, 5G or DSRC communications, right? You really have to work with government bodies and state and the center. So I think my last comment, and I know that there's not much time left, but I'm going to open it to Q&A now. But last comment is that with all this complexity happening in the world around us, right? I mean, systems are becoming more and more complicated. systems are becoming autonomous, they are becoming automated, autonomous, and all these nice features and properties. My concern is not cybersecurity. That, of course, we'll have solutions. My concern is that humans will never accept fully autonomous systems. I'll give you an example. Will you ever fly an aircraft, let's say from Delhi to the US, when the pilot announces that there is no, let's say you get an announcement in Delhi departures, international departures, that this aircraft has no pilot. It's completely autonomous. Will you ever fly such an aircraft? I will never fly that aircraft. No. Because there's nothing like human beings, their deep expertise and experience. It will be a long, long time before we have systems that are going to completely mimic the human mind. No matter how much they mimic, will be errors, there will be faults, there will be cybersecurity bugs, there will be attack vectors, right? There will be system failures, right? So I will never ever sit in the car which is completely autonomous. I will never sit in a train or a aircraft which is completely autonomous, which means that there is no driver at all, right? So I think one has to be careful about this whole, craze of autonomous systems going forward, because I think my last statement, they will coexist with human beings. And that coexistence will lead to new areas of research, such as what I mentioned, the human-computer interaction, the human-computer collaboration. How do you do it efficiently? And how do you do it seamlessly? I'm going to stop here. Thank you so much for your attention, and I'll be very happy to take any questions from any one of you.
Sir, thank you so much, sir, for such an in-depth session on self-driving or smart driving and autonomous vehicles, sir. We have few questions in the chat box. I'll read it for you, sir.
Sure.
Then we'll take the question from audience if they want to ask. The first question, which has been asked by Professor Panse ma'am, that which simulation tool is used to do research in vehicular communication? Which simulation tool will be useful?
Sure. Yeah, that's a good question. So see, there are many simulators you could use. There are many simulators, right? So one of the simulators that you could, look, there is a NetSim, which is very good. NetSim is, by the way, a Bangalore-based company in India. It's doing very well. NETSIM, NetSim. So you could look at NetSim, you could look at QualNet, you could look at OpNet, you could certainly look at even NS2, NS3. But I think, in my view, NetSim is a very good simulator, primarily because it's from our folks in Bangalore in India, and I know the people very well. They keep coming for the demos in our CommsNets conference. They're doing very well. So I think you should really explore a partnership with NetSim. They will give you great discount, primarily because you're from the university. Yeah, so I think that's a very good, because OpNet and QualNet are going to be very expensive. So you don't have to go there. You can work with NetSim. I hope that answers your question.
Okay, sir. I'll just take your answer as a NetSim. Second question has been asked by Professor Sushil Chauhan. Is there any specific language which we can learn and understand to implement autonomous system using AI?
Not really. I mean, I don't think there's any specific thing dedicated to. Look, yes, there is a whole standard called, there is a whole set of different standards for automotive systems, right? That's called the AUTOSAR standard. So please take a look at AUTOSAR, AUTOSAR. So AUTOSAR is a whole framework, the architectural framework for vehicular, autonomous systems, vehicular networks and autonomous systems. But there is no specific language. I mean, you could use, and typically they use Python in machine learning AI.
Yes,
it's a mix of Python, C, C++. There's no dedicated language as such.
Yes.
There could be many languages, but the whole framework is called it's worth looking at the AUTOSAR framework.
Okay, sir. Thanks a lot. The last question is in chat box is, why autonomous vehicles rely on edge computing and not on the cloud computing?
Can you repeat that, please?
Why autonomous vehicles rely on edge computing and not on the cloud computing? This question has been asked by Professor Prachi Parsotkar ma'am.
Yeah. No, good point. And I did emphasize, but I'm going to repeat again. Cloud is too far. See, cloud is sitting very far. And by the time you send data, you aggregate data from the vehicle and you send it to the cloud. And let's say it's kind of processed in the cloud and you get back the answers. It's going to take a long time. Please remember, these are real-time systems. You need answers in tens of milliseconds. Am I right? These are
Yes.
real-time systems. You cannot afford the latency of a cloud. It's too far. And edge nodes are much closer to the vehicles. And so first you will process your data at the edge using whatever, CNNs or DNNs or federated learning or whatever. You'll process the data at the edge. Final results will of course go to the cloud, but that's a final result. You will do intermediate processing at the edge because it's much faster and much quicker, closer to the vehicles. I hope that answers your question.
Yes, sir. Yes, it's very clear, sir. One more question I'm having, being a civil engineer, sir.
Right.
Whatever you have explained, it's very in depth and very innovative in the area of self-driving or autonomous vehicle. But do we need some same kind of innovation in the area of infrastructural development, which will assist autonomous driving very well, or there will be less, you can say, accidents in the future, or we can improve the safety? And can government should look at a serious matter and draft some guidelines, and they should come up with some kind of new, you can say, approaches in the transportation sector.
Right.
What is your
Yeah,
opinion on that? Yeah.
Yes, I agree with you. I think I think you asked a very important and a very fundamental point. I think the solution will not just lie only with pure technology. The solution to better safety on the highways in India or anywhere in the world would really depend upon better governance, better supervision, better monitoring. Also, we need to put very stringent checks and measures. I mean, look at the number of accidents happening because these young kids are driving their parents' vehicles, right? Young kids who are underage are driving the expensive vehicles, and they're killing people left, right, and center. This should be unacceptable. In fact, way back, I am of the view that if any child under a age without a license, underage or without a license, is found to cause accidents on the road, leading to somebody, leading to some fatalities, right? You should not arrest the child, arrest the parents, put the parents behind bars. I mean, why are we not announcing stringent measures? Put the parent for 1 year behind jail. Now, let me see how many children will drive the car just because they're rich. How many kids will drive a car because they're rich or when they have no license. See, you have to have strong deterrence. Technology cannot do that alone. You have to have, as you rightly said, strong, measures, not just measures, standards in place, policies in place. And I think, we go so easy at times at the expense of people who are being killed on the road. It's very unfortunate. So I think but I must say that, our Honorable Minister Nitin Gadkari is doing a great work. I've met him. I've happened to know him. He's a great person. He's doing so much for the country in transportation. But I think you need very stringent laws, which are hitherto lacking. And the fines are too little. They're too little. Why don't you impose a fine of 25 lakhs if you kill someone on the road, or 500 million? Then let's see how many will ever make a mistake, right? And if you can't pay the fine, you're in jail for 10 years. So this system needs to improve.
Aggressive implementation.
You have to be very stringent about your laws, rules, regulations, coupled with technology.
Yes.
I see a question here from Vikas Gupta that edge devices may not be that powerful as compared to cloud. Well, very good question. Vikas, you're absolutely right. The edge devices are not as powerful as the big servers in the cloud, but they're getting to be there. And by the way, you're not going to process your entire data at the edge, right? So the answer to your question is, you have a big chunk of data, you're going to process small chunks one by one, and that you can do at the edge. But the entire chunk, of course, will be at the cloud. But you cannot do without the edge, because edge will provide you real-time processing, which will not happen with the cloud. So the answer to your question is, you will divide the large big data into smaller chunks, process it one by one in the edge very quickly. Because remember that the link between the edge and the cloud is a very high speed link. Okay? It's a very high speed link. So that capacity is also going up.
Yes. Is there any more questions? You can just post it in the chat box. I think most of them have asked the question. Yeah. Now they have started saying thanks to you, sir. Yeah.
I hope my talk was comprehensible. I hope I kind of.
Yes, it was inspiring, sir. Uh, Thank you once again, sir, on the behalf of International Relation Office and Electronic Department, YCC, for your valuable guidance on this particular topic of self-driving and autonomous cars. Uh, I request you to accept the token of appreciation on behalf of organizing team and Yeshwantrao Chavan College of Engineering for giving us your valuable time. Thank you once again, sir. Thank you so much. Yeah.
Thank you very much for this opportunity. It was indeed a pleasure. By the way, nice questions. I enjoyed the questions.
Yes, sir.
Should you have any additional questions, please send me a message on LinkedIn or Facebook. LinkedIn may be better, I guess. I will certainly respond to your queries, okay? Or you can send me an email at rajivshori@gmail.com. Thanks so much to the team behind the FDP at YCCE. It's a great pleasure to be here. We'll be in touch. Thank you so much. Have a wonderful remaining part of the FDP.
Yeah, even it was very beneficial for all of the participants as well, sir. Thanks a lot, sir, for your precious time.
Excuse me, sir. 1 minute, sir.
Yeah.
All the participants are requested to please turn on your video for the screenshot.
Yeah, I know. It's good to see who's there. Very few are coming on the video, right?
Thank you, all the participants. Thank you, sir.
Thank you very much. Have a great day.
Yes, sir.
Thanks again. Bye-bye. Signing off.
Thanks again, sir. Bye.
So the next session start at 12:30. Okay, 12:15. So stay tuned.
Dear participants, join us at 12:15. Our next session would start at 12:30, but before 50 minutes, you will have to join the session.